Did you have any questions from the homework? Anything from last night?
Run caffeine.
I'm sorry, what?
Run caffeine.
Run caffeine, yes, so it doesn't kick off. Caffeine. Stop it. There we go. All right. So 23 through 32 were find the derivative of the hyperbolic function. And like you said, it wasn't very difficult because the formulas are actually the same as differentiating circular trigonometric functions. Just put an H on them and then go. Yes, yes. And remember the way that I discovered, I don't know if any of y'all had thought of it, realized it before or not, but in looking at all my integration formulas, I realized that the ones that involve sine or cosecant, which are just reciprocals of each other, or tangent, which has sine in the numerator, those are the ones that have negatives. And then cosine, secant, and cotangent did not have negatives. All right, so let's just do a few integrating hyperbolic functions. Page 372. And the first one I had circled was number 46. If you were to take a wild flying guess, what do you bet U is? That's a pretty good guess. You're starting to develop an intuition for this. So whether I do a formal change of variables or not, I'm at least thinking U is square root of X, which is X to the 1/2, and therefore du must be what? X 1/2 X to the negative 1/2, or negative 1/2 square root of X.
When would U be X to negative?
Hold on, I was thinking. No, I'm just letting U be the positive X to the square, or positive X to the 1/2, because I'm assuming that I'm going to integrate cos U, and that this is going to be part of du. I think this is going to end up being part of du.
Wouldn't that be positive 1?
Yeah, yeah. I was just about to check that because a half times 1 is a half, and then subtract 1. So the exponent was thinking when you integrate, you pick up that negative. All right, so that dx is du. And so can I write that in a form of something I can integrate? I can integrate cos square root of X as long as I have dx right beside it. That's what I want to have. Is there a way to make that equivalent to the line above it legally? Yep. And then double check that everything's equivalent. And this is cos u du. And then what's the antiderivative of cos u? Just gonna let you say it out loud for the fun of it. Now, do you see why, Izzy, why u needed to be just square root of X? That square root of X in the denominator just ended up being part of du.
Sure.
Yeah, this wasn't cosh square root of x to the negative 1/2. It was cosh square root of x to the 1/2. So x to the 1/2 is what I needed to let u be. What about 48? We're just gonna go with the first u somebody suggests, and then we're gonna find du and see if we can make it fit that. If not, then we'll have to erase and try a different u. But what does your gut say to let u be? What do you think?
My guess telling me to have 1 plus sin h squared looks like it could be changed to something else.
The whole denominator? All right, so let's try that.
That's looking like it can be changed into something else.
Okay. All right. So you're not talking about picking u yet. You're saying rewrite that as something else. What's our fundamental identity of hyperbolic trig functions?
Cosh minus sinh equals 1.
Cosh minus sinh equals 1. And I'm not good at doing things in my head. I got to write them down, look at them. Actually, squared. Yeah, cosh squared minus sinh squared equals 1. So is there a way to get a 1 plus sinh squared out of that? Yeah, absolutely. That equivalent to the line above it? All right. Are you ready to pick a u yet? What do you think? The whole cosh squared is u? I'm going to write it like that so that because that's how I wrote my trigonometric functions to understand where the exponent really was. If I let that be u, then what's du?
Two cosh x times derivative.
Which is sinh. So 2 cosh x sinh x would be the derivative. Oh, no, I hope not. I hope not. Yeah, I hope I don't have to go that route, and I don't think I'll have to go that route, but if I let that be u, then I can look at that as being u to the negative 1. He did come. Yay! I apologize to everybody else. I'm so sorry. I'd had y'all on speed dial this morning. I would have speed dialed you and said something. If we let that be u, then our du is going to have another cosh in it. And we don't have another cosh in it. So either we got to pick a different u, or holy cow, I hope we don't have to go the whole change it to e's route. I thought something else should be u. And what are you thinking?
Continue to just change the equation itself.
Oh.
And secant. Then I brought secant.
I'm interested. I still think I know an easier way, but I'm interested in what you're saying. You're saying let's keep on working on this, and it would be sin sinh over cosh would be tanh x, and then there would be another 1 over cosh, which is sinh x. Holy cow, that never would have occurred to me. Is that right? That's what you're saying, Sam? And then what?
That is just negative c plus c.
All right. let's see, the function whose derivative is sech tanh is, I feel like I'm speaking some Teletubbies is what I feel like. Um, man,
It's negative sech.
yes, because the derivative of sech would be negative that. Wow. That is completely different than how I thought of it, but I'm 99% sure, yep, we came up with the same thing. I like that. I absolutely like that. Let me show you, just to prove that it's okay to think about something differently. What I thought was, I did do this, but then I thought, let u be cosh x instead of cosh x squared, and then du is just sinh x. And let me think about negative real quickly. The derivative of sinh is cosh. Yeah, you don't pick up a negative with the hyperbolic functions like you do with the circular functions. The derivative of cosh is sinh. Derivative of sinh is cosh. Goes both ways. So that way, I was looking at this as being u to the negative 2 with du right beside it. Is that equivalent to that? Yes, it is. And so how do you integrate that? Power rule. So either way works. I like that you thought of something different than I did on that, Sam. Alrighty. What about 52? Well, 52 is going to be easy if we did 48 Sam's way, then 52 is very much like it. Anybody have any ideas? You can't stare at it and think God's going to whisper to you. You have to try something. You let you be something. And then you think, if I let you be this, then what would du be?
What is secant squared times secant?
All right, let's try that. Is that a true statement? Or not a true statement, it's not a whole statement, but is it equivalent to the line above it? Yeah, okay. So how's that helpful? It actually is helpful. That's exactly what I did.
So wouldn't it just be tangent x times secant x?
I'm not sure, William, because you may be skipping some steps, which you're capable of doing, and that's okay. But what did you let u be to get to that point? Or, oh, I know what you're thinking. Oh, okay, that won't work. Let me tell you why that won't work. You were integrating by just taking the antiderivative of each factor. You were taking the antiderivative of this and the antiderivative of that. We can anti-differentiate term by term, things that are added, but we don't have a product rule for integration. So we can't integrate just by taking the antiderivative of the first factor, antiderivative of the second factor.
It's just a power rule.
Yes, because what are you looking at as being the thing that you're going to use the power rule on? Yeah. Well, the u is just sech x, and then the du would be sech x tanh x dx.
We have to add a negative to sech.
You know, I worry about that very last. Because I can figure out the negative at the end. But when you differentiate the hyperbolic functions, let me show you right here. I didn't write it down right there. The derivative of cosh is sinh. The derivative of sinh is cosh. You don't pick up those negatives that you get if you differentiate cosine. The derivative of cosine is negative sine, but the derivative of cosh is just sinh. Look at the derivatives in the book if you're not sure of that.
Then all the like sech and cosecant and all those are all negative. Sech, cosecant, tangent are negative ones for hyperbolic. It doesn't switch from sine like sinh, cos.
Since cosh and tanh are all positive, and then sech, cosech, and cough.
Okay. All right. You know what? I wrote in the notes that you only had to remember the derivatives for cosh and sech, and if you needed anything else, I'd give them to you. And then I promptly didn't memorize the other three, and that they had negatives in front of them. So yeah, I forgot that. I would have had to look that up. So when I did the homework, I was looking at the derivatives instead of having them memorized. You're saying the derivative of sech is negative sech tangent. Okay. And if I have to have a negative here, then I have to have a negative there. And then I'm just looking at that as being u squared. The antiderivative of u squared is 1/3 u cubed. All right. So the only ones you have to memorize for the test are cosh and sinh. And I asked Miss Denton about that because I want y'all to memorize everything she makes her students memorize, but I don't want you to memorize what she doesn't make her students memorize. And her concern was the very same as mine. If you had to remember all 6 of those, you're going to start making sign mistakes, SIGN mistakes. in remembering which ones are positive and which ones are negative. And she felt like it was more important to know the derivatives of the circular trigonometric functions than the hyperbolic trigonometric functions, except for sinh and cosh. So that's why she said give them anything else they need. All right, did I have one more of those? Yes, number 54. Was it different and interesting somehow? 54, well, of course it was. I can see real quickly that it wouldn't do any good to let u be the whole 9 minus sinh squared, because then I'd have to have a sinh cosh in the numerator, and there's no way of getting another sinh in there. So I've kind of ruled that out. But do you recognize that as anything familiar? Good chance it's arc sine. It's arc sine if I let u be sinh, then du would be cosh, and a would be what? Yeah, the thing you squared to get the constant. Jordan, you're starting to smile like, this is kind of fun. I like arc sine of sinh.
Because I get this.
Okay, that's just the formula for arc sine is 1 over square root of a squared minus u squared du, and we've got our du right there. So the formula for arc sine is just arc sine u over a. It's the arc secant that has the absolute value in it, isn't it? Yeah, this one's just arc sine u over a. That would be absolutely fine with me as far as leaving that as the answer. Don't think that arc sine and sinh somehow undo each other. They don't. That's how I would have left my answer. But when I looked in the back of the book, they had this. I just want to make sure you know where they would get this.
That's the formula for.
Yeah, that's the formula for sinh divided by 3 would give you that over 6. And I don't know why they took that step of changing it back to e's when they had not in any other problem. But as long as you understand,
But that was also a negative exponent in that.
They're making it hard.
Just the biggest one.
I don't know. As long as you can look at it and go, that's equivalent, then it doesn't matter to me which one you write. All right, so that's all the integration. I felt like, nope, I wanted to do one definite integral. One definite integral. Any ideas? If that was u squared, and all I had to do was use the power rule, then what would have to be decided? The derivative of the u, and it's not there. So it's something more than just the power rule. Change
We have to
cosh.
write it as 1 plus h squared x.
Yeah, I could do that, but I'm wondering how that would be any better. That was my first instinct, but if I can't anti-differentiate cosh squared, I probably can't anti-differentiate sinh squared either. Oh, no. Surely I'm not supposed to have to figure out how to write that in terms of tangent, sech, or cot and cosech.
You can rewrite it as e to the x plus negative x
I'm-
over 2 times that.
I'm hoping that I don't have to go that route. I'm gonna save that for last resort. If I can't think of anything else, then I'll do that. But I'm gonna think of, yeah, that's always an option. Oh, man. I wish I could think of what I thought of 2 nights ago without having to look at the solutions manual. I wish I could think of it again. I did get it without looking. What was it? Fundamental identity didn't help. I'm starting to think it's going to involve cot and cosech. Oh, no. I didn't get this one up without looking. I just realized, sneaking over here to look at my paper, I did not get this without looking. Look at the identities page for hyperbolic trig functions, where those identities are listed just a few pages back in the book. Yeah, I didn't think of going, well, obviously, that's just 1 plus cosh 2x over 2. That did not occur to me. Oh,
All right, yeah.
all right. No, that did not occur to me.
Will these be given to us if we need them?
Yeah. No, I want you to memorize that whole box of stuff.
That would be the first thing.
No. You have the inside front cover of your book memorized, and if I had told you that in August, you might not have taken Cal 1. But you have it. You have it now.
Yeah, when I first opened this book and saw that page, it's like, I really want to take this. Because I don't know it.
Keep this in mind, Major. Being the exaggerator that I am, I had to marry a very stable man who would calm me down at times. Just so you know, Major, you need that woman in your life. Because you're the same exaggerator than I am. You need a very calming woman to smooth your rough edges. All right, how does that help?
Well, that's not the square.
It helps because it's something that's not. I could bring a 1/2 out front at least. Not have, yeah, I mean, because that's a constant 1/2. And then I can integrate term by term. I can't integrate factor by factor, but I can integrate term by term. And so what is the antiderivative? If I break that up into 2 integrals, what's the antiderivative of 1? Just x. be careful with brackets and parentheses. I've integrated the first term. 1/2 is the coefficient of all of this. So now I'm ready to integrate cosh 2x dx. All right, so you're kind of thinking if u is 2x, then du is just 2dx, which only differs from this by that factor. So as long as, and I'm putting a step in, Chase, that you may not have needed, but I'm putting it in for myself. I would have written that as, can't spell cosh. Cosh 2x 2dx, and to make that equivalent to the line above it, I'd have to have a 1/2 right there. And so that's, I'm going to go ahead and distribute this 1/2 and call this 1/2 x plus 1/4. What did you say? There's my 1/4. What did you say this was? Not 2, just the derivative of cosh u is sinh u. Oh, but this was a definite integral, so instead of plus c, I need to evaluate that at 0 and at 1. So far, so good? All right, and with 1 in the place of x, I have 1/2 plus 1/4 sinh 2, and subtract what I get when I put 0 in place of both x's. 0 plus 1/4 sinh 0. What's sinh 0? Yeah. Put a 0 in place of both x's right here, and you're going to have 1 minus 1 is 0, 0 over 2 is 0. So that's 0, that's 0. All we have is this. And that's absolutely fine. That's where I would stop. Let me see what they did in the back of the book. In the back of the book, actually, they left it that. Oh, man. Hold on a second. One half. 1/4 sinh 2. Oh, man. That's absolutely fine. That's not the answer in the back of the book. And what makes this occur to somebody, I do not know. Is that a true statement? I mean, not a true statement, but is that equivalent to the line above it? And then they use the double angle formula for sinh 1. I don't know why. The double angle formula for sinh 2 times 1 is 2 sinh 1 cosh 1. And then what is, let's see, what do they do after that? Obviously multiply the 4th times a half. Yeah, they just left 1/2 plus 1/2 sinh 1 cosh 1.
So dumb.
Just because it didn't occur to you doesn't make it dumb. And I mean, I was absolutely fine with my answer. I think this is not any simpler than that.
It's much worse.
But it's important that you be able to check your answers in the back of the book. And in order to do that, you've got to recognize equivalent expressions. So I figured out why that was an equivalent expression. All right, let me give you one other piece of exciting news. This may be the most stunning thing of all that I first say learned, but actually I guess I knew this once upon a time and just remembered it. The two most amazing things on my 5.9 notes are that -1 equals e to the pi x. That's pretty darn stunning. The other second most stunning thing is that spiders know calculus too.
I don't think they know.
Oh, spiders know cal too. Spiders build catenaries, which proves that they know cal too. This shape of a cable suspended between 2 points and pulled down by gravity, that shape is called a catenary. And while humans are struggling to build these towers, spiders are going, na na boo boo, and the catenaries. And every one of those is that same shape of a cable suspended between 2 fixed points. That gives me chill bumps. Oh, a catenary is a curve assumed by a hanging flexible wire chain when supported at its ends by a uniform gravitational force. Examples of catenary curves are power cables suspended between 2 towers, simple suspension bridges, chains for anchoring ships. That makes sense. If you have a chain attached to the ship and a chain attached to the, I forgot the word, anchor. Anchor, that chain between them is acted upon by a uniform gravitational force. It makes that catenary curve. And offshore oil rigs and spider webs. The general form of the equation of a catenary is y equals some constant a cosh x over a. And so this whole time, spiders have been smarter than you. A model for a power cable suspending between 2 towers is given by this equation for x's between -25 and +25. And then they provided the picture for us, and then I graphed it on my TI-83 just to see what it looks like. But if we call the point directly beneath the tips of those 2 towers B and -B, B is 25. So our towers are located at 25 and -25, and the cable between them is modeled by that equation. I need to show you that. You actually, let me pull up my TI-83. I had to Google where to find cosh on the calculator. And I just did it the other day, but do I remember? Was it under math? Oh, shoot. Where was it? I might have to Google it again real quickly. Math. The time in which we live is so wonderful. If I had wanted to find this out when I was a kid, well, when I was a kid, they didn't have graphing calculators. But if they had, I still couldn't have looked it up on Google because Google didn't exist. I had to wait till my mom took me to the library. Come on. Go away. Stop it. It is under catalog. Second and catalog. Catalog is right up above the O, 0. So second and catalog has a ton of stuff, but if we type the letter C, we'll at least get down to the C's, and the letter C is above which key? Program? Or maybe not. Maybe I'm just gonna have to scroll through till I find it.
I tried that.
I'm getting close. There it is. There it is. So I should have pulled up y equals before I got to that, because that's how I graphed it. I had to go y equals and then pull up my catalog menu and scroll down to Koch. Which was right there. Y equals Koch what? X over 25. X over 25. And I didn't type in the rest of the equation first, but I can say that times 25 plus 18, and it should be the same thing. Because the calculator's going to do x divided by 25, and then it's going to take Koch, and then it's going to multiply that by 25, and then it's going to add 18. So, graph it. And that's a window that I had from some previous life. Change it to standard window.
Still not right.
All right, and that's not acceptable. So I'm going to do two things. I'm going to check to make sure my calculator's in radian mode. And it is. I'm not sure that even matters, but I'd think about it for a while. And then I'm going to change my window, because I suspect it's just outside the window I had. I want to graph that from negative 25 to 25. Negative 25 to 25. And then I suspect that it's just, let's say, counting by fives. And then I suspect that it just goes higher than my max 10. I'm going to make my max 100 and count by tens. Ah, there it is. Doesn't that look like a cable wire that is sagging, and someone needs to go fix it? All right, that's the graph that I have here. Here I graph from negative 25 to 25 by 5s, and my graph was 0 to 80 by 10s. How would I find the height of the cables at the towers? How do I find these two heights right there? What, Jason?
So that's the question.
Oh, you can do it. How do I find that height right there? I could, but let's play like I don't have a graphing calculator.
Plug in negative 25 into x and 25.
Negative 25 or 25. This is supposed to be the same height. So this should give me the same answer whether I put in a positive 25 or a negative 25. But that's the height of the cable at the point where x equals 25. And this is the point where x equals 25. And that's the point where x equals negative 25. So at x equals plus or minus 25, y is 18 plus 25 Koch, what would that be? 1 or -1, and it should give me the same answer either way. So to evaluate that on the calculator, and let's say I didn't have the graph, let's just show that it gets the same thing. If I couldn't trace the graph, how would I find it? I would say 18 plus 25 cosh cosh 1. Ah, what did I do? I didn't hit enter. Let's just start over. Second. Yeah, I'm still in alpha mode. Enter. Cosh 1. Ta-da! About 56.6.
If you really want to be exact, it's 445,544 over 7,875.
Which is e to the pi x times something. I suspect for the cable dudes and dudettes, 56.6 is probably good enough, or 56.7 is probably good enough. And just for the heck of it, if I wasn't having such trouble getting the cosh on my calculator, I'd do 18 plus 25. Actually, all I have to do is second and entry will pull that back up and let me edit it without having to type it in again. And I can go back and make that a -1. And same thing. So the height of the cable at the towers is 56.7. And we're not given any units in this problem. I assume it's probably feet. That maybe sounds right for that tower. But we really don't know that. It's 56.6 something. Oh, that was 0.6 instead of 0.7, wasn't it? Yeah, 56.6 somethings. All right, find the height of the cable at the midpoint between the two towers. How would you find that? Well, if this is -b and that's +b, then right here is where x is 0. So at x is 0, y is 18 plus 25 cosh what?
0.
And do we know cosh 0? Yeah, we put 0 in place of both of those x's right there. We're going to get 2 over 2 is 1. So this is just 18 plus 25 is 43. Somethings. We don't know what's. And then for the most fun of the day, find the slope of the model at the point where the cable meets the right-hand tower. What does that sound like? That sounds like finding the derivative. Find the slope of the model at the point where the cable meets the right-hand tower. That means right here, find the slope of the tangent line. And so, all right, slope of the tangent line. Y prime is, what's the derivative of that?
25, 6.
Actually, I didn't mean to point there. I meant to point up here. The derivative of the equation. Derivative of a constant is 0. The derivative of 25 cosh x over 25 is, talk to me. X. The derivative of cosh u is sinh u du. And that is just sinh x over 25. Is that a slope? That can't be a slope. Slope is a number. That's an equation for finding the slope. Now we want to find the slope where? Right hand point, and what? How does that translate to numbers? X equals 25. At x equals 25, y prime equals sinh what? Which is what? I don't know. I have to find it on the calculator. Yeah, I cranked that up on the calculator and just double checking. Yes, I got 1.175. Somethings. We don't know what the somethings are. All right. The slope of a spider web. Who would have thought we would ever reach this point in our lives? Homework is finishing up 5.9 and then just integrating everything you can get your hands on this weekend. You eat a pizza, you integrate that pizza before you eat it.
I don't know.
We can have an integration party at my house. The practice test is mostly the Chapter 5 review, roughly 31 to 94, all of them, and I gave you the even answers and the odd answers, so you can do all of them. The only ones I would do in addition to that Chapter 5 review are the few things that I noticed, hey, there wasn't one of those on the chapter review, like when you're integrating this, or when you're taking the derivative of an integral with the second fundamental theorem calculus, and the top limit's not just x, it's x squared or x plus 3 or something. You need to practice that. You need to practice, what do I do when I've got an extra x in there? Got to practice, oh, I need to divide, so it's in the form of log integration, and oh, I need to complete the square to get it in the form of an inverse trig function. All right, Monday you ask me anything you want to. Tuesday we'll come at 6:15 and take a test. I'm kidding, because that's what I do. All right, see ya. Thank you for coming today. It's amazing that y'all all showed up on a day Cumberland County schools were delayed.
I do.
Huh?
I do.
Well, I can't read the writing, so I'm not sure what it's supposed